this is where we left off on Friday. And basically for law of sines, if you have a known side opposite a known angle, and then one other side or angle, you can solve the whole triangle. That's what it is. Are you, who were not here Friday, do you have some remembrance of what the law of sines is? Carmen, Katie, Willie? No. Some did. Some had some memory, but it was a long time ago, 2 years ago with Mrs. Clausen, and she probably didn't spend as much time on it as we're spending in this class. So that's it. So basically that's what it looks like. And when you have a known side opposite a known angle, do you have your ACP formula charts? I want you to go ahead and put that, go ahead and recognize where that formula is. I'm going to show you where it is. It's right here. Here's your formula chart. I want to show you where it is, the law of sines. It'll pop up sometime, I hope.
You can join.
There it is. Okay, here's the law of sines right here. Do you see this in your formula charts? Carmen, you have your formula chart out? You know where to find it? Do you have your formula chart?
I cannot find it.
If you can get another one, I'll give you another one if you want one. I don't think I have.
No.
I don't think I have a colored one, but I have one of these black and white ones.
Your calculator's on it. Change it to degrees.
Here,
There's
here.
degrees and radians, change it to degrees.
Okay. So this, for any triangle, law of sines holds true that the ratio of the sine of an angle to the side opposite the angle, and little a is opposite the big angle B, little b, which is side B, is opposite the big angle B, little c. So these ratios are true for all triangles. So that's basically the law of sines. And to make the arithmetic easier sometimes, I like to turn the equation upside down. That just might make cross multiplying a little easy, avoid a step or so. So that's really all, that's what it is. And this section here, sections 5.5, it's the law of sines. Next section we're going into is going to involve law of cosines and Heron's formula. So that's kind of where we're headed the next couple weeks. So anyway, that's that worked out. Now, in problems 5 through 12, we don't have what? We don't have the drawings, right? So you have an option of possibly working these without drawings. If I have the time for it, like to make a drawing. Why do you think I like to make a drawing?
It's easier to understand.
Easy to understand, and one other reason besides that.
So you know where to put all of your stuff.
The reason it is because it lets me know if my answers are reasonable. If I have a drawing, I know approximately what to expect. So if I know we have an angle A, like this, I'll say this is angle A, which is 40 degrees. And then we have an angle B over here, which is 30 degrees. So here's angle B, here's angle A, and you're given side B, and so side B over here is going to be 10. And so I know this is going to be angle C, and this is little c. And so basically what I'm looking for is, what does this tell me about side A inside C. What does that tell me?
They're gonna be bigger than 10.
It's going to be bigger than 10. Who said that?
Emma.
Emma, okay, that's really good work. I'm going to give you some credit for that, Emma. That's good work. Yes. And we know this angle is what?
Bigger than 90.
Bigger than 90. And we know it's got 110 degrees, right?
Yeah.
So big C equals 110 degrees. So now we can solve for our unknown sides, right? So I would say that this case we have little a is to sine of 40 degrees. That looks like 5, doesn't it? Sine 40 degrees equals
10 sine.
10
over sine 30.
of sine 30 degrees. And so now solving for a is equal to
10 sine.
2 times 10 times sine 40 degrees. So a is equal to, I'll say approximately equal to, and 20 times sine 40 degrees, 20 sine 40 degrees. Where did I get that? So I get 12.856, is that it? Where did I get this 2 from?
I don't know, that's not how I did it. When you,
Use circle.
yeah.
Unicircle, it has to do with unicircle, right? Because I know the sine of 30 degrees is what?
0.5.
0.5, right? And I know dividing by 0.5 is the same as multiplying by 2. So that's where it comes from. Now, unfortunately, most of these problems we work with, starting the next one, I don't think has a standard sine 30 degrees, but, so we have that. And the next one we have is, so we have that one, we need to find little c, right? So little c is equal to, and I'm just going to say, I'll say little c over sine of 110 degrees equals, I just keep the same ratio here, 10 over sine 30 degrees. So little c is equal to 18.794. So does this, remember what Emma said about the relation to the side lengths? Do these answers then, in light of that, seem reasonable?
Yep.
Yeah, they do. Okay, so that's good work. What I want you to do is go ahead and work on number 6, and I'll choose somebody to help us out with number 6 here in a couple of minutes. How's that? Are you okay on this, Will? You're a little lost on this?
So that first step, how do you get from that, those fractions to the a equals? I don't get where the sine 30 goes.
Okay, it has to do with the law of sines. If you look at the law of sines, which is sine A over A
Yeah,
equals sine big B over little b
I understand that.
equals sine big C over little c. So what we're doing is we're taking this thing right here. We're taking A and B
Yep,
right here. And what I did is I turned these things upside down. So I'm saying A over sine A equals B over sine B.
right,
And then that's what this is.
yeah,
A over sine A equals B over sine B. And then from here on out, it's just solving for A.
right, but where does the sine 30 magically disappear to?
That's because on the triangle, if you look at it, it's the same as 1/2. That's why he was talking to change this to 2 on the other side.
If you have them up at 70, right?
So you could write it as sine 30, you just put 2?
Yeah, what it is 1 divided by sine 30
So that's the missing angle you're missing. And then
is equal to 1 over 1/2,
So you put it underneath.
which equals 2. So I just took a shortcut because I happen to know what sine 30 degrees is. I know that's 1/2.
If it's not,
I feel like that.
So if I don't know that, so maybe I'm confusing you by by getting 2 cubed, okay? So it's going to equal to 10 sine 40 degrees over sine 30 degrees,
Okay, that's,
which is 2 times 10 times sine 40.
correct. Okay.
Does that help strike?
Yeah.
So I kind of distracted you with that little
Yeah.
sleight of hand, okay? Because what it is, I saw it as an opportunity to reinforce the unit circle thing. So that's why I brought it up like that. I wasn't intending to confuse you. I'm intending to connect to prior learning a little bit. Did you find it when you were doing number 6? Did anybody draw a picture for number 6?
Yeah, I drew a picture for all of them.
You drew a picture for all of them? Okay. Because because in the other class, most people didn't. Do you need to draw a picture for these?
No,
Probably not.
it just keeps it, makes it easier for me.
Yeah, that does for me too, and probably for most people. So let's go ahead and, so you ready for me to call on somebody for number 6?
Yep.
Okay, let's do that.
As long as it's not me.
But what if it is you, Will? You'll be fine.
You'll have to wait.
Yeah, because Will was doing a good job as a student and asking questions. Okay, this one right here. So here we go. It's going to be Will or Emma, Will or Emma, Will or Emma. It is Will. It almost went over to Emma, but it got Will.
We'll be here, man.
Okay, Will. Yeah, it caught Will. I don't say unawares. He was just busy trying to figure out, having not been here Friday. All right, Will.
Right here, it's sine 40. Across from it, it's sine 40. Okay, parentheses, sine
Do you want me through it?
Yeah, sure. Okay, just, did you do anything first on this?
I'm trying to figure it out.
Okay, basically what you're doing is you're taking angle C is equal to 180 minus these two.
Right, which is 68.
So big C equals 68 degrees. And then really, as far as what this thing looks like, is these angles are all kind of close to 60 degrees. So it's going to look roughly like an equilateral triangle, right? So A, B, C. And so here you have 50 degrees. Here you have 62 degrees. Here you have 68 degrees. And then you know this side here, little a is 4. So what you have is you can find out any one you want. So you put little b over sine of 62 is going to be equal to little a over sine 50 degrees. And then you solve for little b here. Then over here, you want to solve for little c over sine 68 equals 4 over sine 50 degrees. So you solve for b. Hey, next one, Mark? Yeah, I sure do. Let's get you here. This is a good one right here. This is good. Okay. Does that make sense?
See, yeah, I think I'm getting it.
Yeah. You're catching up a little bit. So B is sine 60 times 4 over sine 50. Sine 60, sine. Man, I just forget stuff. Yeah, sine 62, 4 sine 62 over sine 50. So 4.610, does that look right? So that's a little b, and it's going to be bigger than 4.
Right.
And this next one here is still going to even be bigger than that, because you have 4 sine 68. 4 sine 68 over sine cosine. That's not cosine. Sine. Oops, divided by. Okay, we'll have to insert that. Let's see, second, insert, divided by, there we go. Oh, I'm just mishitting these buttons here. That should be good, right? So 4.84, does that sound right? 84.1. So 4.8, so that's it. Okay, you're working that out over there. Yeah, so she's doing it. Yeah. And she's doing it as a single equation there, which is fine. You can do that.
It just seems a lot easier than that.
Yeah, it is.
It's like a lot.
No, really, it is good. This is good. This is really good. I like what you did here. Add this thing here. Okay, this, when you put it out as a single equation like this, I've never seen anybody do it like that, but it's like,
It's way better, that's for sure. It's way easier.
yeah, if it helps you see it. Okay, what Kinsey did She set this up as a single a whole equation right here. So now what she does is she can solve for her unknowns one at a time here on this. So this is all the solutions in place.
Yeah, I think that should be.
And so if you take these,
Bigger number?
each one of these is equal to each other.
The bigger number, the bigger the angle.
Whereas what people do mostly is break off pieces of the law of sines equation like this.
I like it, Kenny.
Yeah, this gets helpful. Okay, let's go on to number 7. I could choose somebody for number 7, I hope. In a minute. Oh, I forgot to hand back some of this classwork.
More like, I don't
There it is.
Alright.
No, there's no right angle. So what you have is you have to solve for this sine or something. Inverse sine.
So you don't just
No, you can't, because you don't have right angle, right? You don't have, or you don't, you probably don't have a right angle. I guess it could possibly be, it could work out that way. Okay, what I want to do is 7, and then I want to skip 8 because it's similar. Or should I go right to 8? I'll skip, I'll just go to 7. Okay, I'm going to get Angel or Kayla. Kayla, you are 7.
A equals 4.057 and C equals 7.258.
Oh, yeah, I got choice fixing.
And what'd you say C equals?
7.258,
Okay,
and big C is 77.
and big C equals 77 degrees. And then really what you have is A equal sine 33 times 7 over sine 70, is that right? And C is equal to 7 sine 77 over sine 70, right? And so that's how she got those, and these would be our correct answers. All right? Okay, questions on number 7? And I do want to skip number 8 just because of time situations. So we are to number 9. And I've had some questions about number, because this is a somewhat different looking problem.
Yeah, I've tried.
But this is your known side opposite your known angle. So we know that the sine of this angle here, the ratio of the sine of this angle to this side is equal to the ratio of the side of the unknown b. So we'll put sine b over 11. So solving for sine b equals 11 sine 32 degrees over 17. How do you solve for b?
You do that and then you times it by the inverse stuff.
Yeah, so we have inverse sine of 11 sine 32 degrees over 17. Can you see that? That's 11 sine 32. Is that legible? I hope so. If so, you're not complaining. So what I want to do is take the inverse sine, 11 sine 32 over 17, inverse sine 11 sine 32 over 17. So you should get 20.053 degrees. Does that look right?
Yes.
So that's going to be angle B, and then angle C is equal to what? 180 minus 32
128.
minus 20.053. So angle C is equal to
127.947.
Yeah.
0.947, 127.947,
Yes.
and that's degrees. So now we have little c over sine 127.947 equals 17 over sine 32 degrees. So if you cross multiply 17 sine, and I'm going to use that's 127.947 divided by sine 32, is that it? So you should get this. Does that look right?
Yes.
25.298. .298, and that's going to be little c. So little c, big C, and big B. Okay? Does that make sense a little bit? No? It's the same formula that Kinsey put up there, right? Same formula. So what I want to do today, we don't have a whole lot of time left. I want to choose somebody for number 10, and then we'll probably lay it down from there, and then get ready to finish this up tomorrow, and then go into law of cosine starting tomorrow, which this leads into. This is going to be Emily. And I'm going to give Hannah credit too for remembering that inverse sine thing. That's really good. Okay, go ahead, Emily. You got this one?
Yeah, from passing,
send it with you because I haven't got hold of it yet, so. So, I drew a picture.
Drew a picture, okay, so you got angle A, something like this. All right, so that's angle A. And then side A, you said was 32.
Yeah.
So some angle over here, some side over here is 32 is what you're saying.
Yeah, 32.
That equals little a. And then little b is going to be,
Close to,
it'll be close to that length. So it's going to be more look like this kind of.
yeah.
Okay, so I've changed my drawing just based on what it looks like. So b equals 28, we'll say. And we want to find what this angle b is.
So we're going to do, can you put 49, like a big A so I can,
Yeah, so 49 degrees.
okay, so then we're
And that changes the angle here too, the way it looks. Go ahead.
Sine 49 over 32 is equal to sine of B over 28. And then that calculator.
So b is equal to inverse sine of 28
Times sine of 40,
sine 49 degrees over 32. Okay, so what'd you get for big angle B?
I got 41.328.
So there's that. Okay, that's your angle there. And now C.
Our first added a angle A and angle B,
Okay.
which is 90.32A, and then I subtract that from the AB.
It'll be 89.672, right?
Yeah.
So then you have little c, which you don't know yet.
Yeah, so it's gonna be, I guess I'm gonna use a,
Yeah, equals 32 over, that's supposed to be 32,
sine
Oh.
of 40.
sine 49 degrees. And that's not very legible, I'm going to change it to 30. So little c is equal to,
42.34.
34,
Yeah, because it rounds up.
320.
And it's actually 42.399.
Okay, so 340, yeah. Okay, so that's it, right?
Yeah.
So we're going to just leave it there today and we'll be ready for tomorrow. Our bell's going to ring any second now. I'll give you some stars.